Hello everyone, myself Satyam, and I am welcoming you to the my channel Code It Yourself. Today we are going to solve a problem of a binary tree in which we have to find a lowest common ancestor of a binary tree. So let's first see what is the definition of lowest common ancestor. Lowest common ancestor is defined between two nodes P and Q as the lowest node in a tree T that has both P and Q as descendants. What does it mean? Let's see this figure. Here we can see that if I'm asking that what is the lowest common ancestor of X and Y, what would you say? This dark green would be the dark green node would be the answer of this question, because this is the this is the most nearest to the x and y, which is common to both the x and y. So this node has two descendant x and y uh, in left side and right side. So this node is the common ancestor, lowest common ancestor of x and y. So let's see what are the use cases of this lowest common ancestor and why we are studying this. So one of the most used is the computation of lowest common ancestor may be useful, for instance, as part of procedure for determining the distance between two pairs of node in a tree. The distance from V to W can be computed as the distance from root to V plus the distance from root to W minus the twice the distance between the root to the lowest common ancestor. So let what this is saying that we can, if we want to find the distance between x and y, we will first find its lowest common ancestor, this dark green node. Then we will find the distance between this root to the x node, and then we find distance from root to y node, and we will add those distance and minus the twice the distance between root node and the lowest common ancestor node. So another use cases of this lowest common ancestor are as follow. You can see here, it is it is used in the implementation of object oriented programming system, and it is also used in LCA problem. Can also find application in modules of complex system found in distributed computing. So let's see how we can implement in this problem. So let's say in this example, here example 1, if we want to find the what is the lowest common ancestor of 5 and q equals to 1. So let's see in this 5 and 1, this is definitely by observation you can see that 3 is the lowest common ancestor. So that's the answer. And the second, let's see the second example. In this page 5 and q is equals to 4. So here is 5 and here is 4. So lowest common ancestor of both of these is itself 5, because 5 4 is a descendant of 5 itself. So in this case 5 would be the answer, right? uh, you get the feel of what is the lowest common ancestor of a binary tree. Let's see what are the algorithms by which we can determine the lowest common LCA of a binary tree. So first intuitive approach could be that just find the all the paths from root to the our target node, and similarly find the second path from root to the second target node, and just compare both the arrays. And whenever there is a not equals to, there is a different value in the array, then we break that, we will break at that point, and we will return the index which is just before that uh, index, right? So this is the intuitive approach. Like obviously if we want to uh, find the common ancestor, so just append this. For this example, p equals to 5, we will append 3 and 5 in the array 1, and for q equals to 4, we will append 3, 5, 2, 4 in the array 2. So now we will compare array 1 elements of, now we will compare elements of array 1 and array 2 iteratively. let's first we will compare three. um, there is 3 in both the array 1 and array 2. There is 5 in both the array and array 2. But in case of when we proceed further, we are not seeing 2 in the array 1, so we will break this at this point, and we will return the index of this 5, and this will be the answer. So let's implement in our code here. So we want what? We want two paths, right? So let's start with path 1 is something like that. This path 2 equals to this, right? And then we want what? We have to compute this path, so we need a helper function like definition helper function, where we are passing uh, yeah what I am talking is we have to make a helper function. So what would be the argument of this helper function? uh, Argument of this helper function would be the root itself, and path, and the key that we want to find, right? So first of all, let's see uh, if there is no root, then return. If not root, then return, right? So now now we append the root in the path, because we started with the root. So here we are appending the root. So here we will append the root. So append append the root using that path dot append root, right? And let's say if root itself is the no the target key p, so then in that case we will simply return the root itself. Let's say if root equals to key value, then simply return root, right? Or if this is not the case, let's say root is in the left subtree of the tree, or it might be in the right subtree of the tree. So in that case we want to check, we just want if this is a boolean, we want to return a boolean out of this function, right? uh, so let's iterate this because we want a boolean only. So path dot append root, and if root is its node itself, then return true. And if root is not the target key, then we will iterate over this tree recursively. So see if uh, root dot left not equals to none, right? And and root, we will self dot helper, call the helper function uh, root dot left path and key value, target value. And is we can find the target key in the left subtree, or what can happen is we can find it in right subtree. So for that we will write root, there is a typo here, it should be root dot right is not equals to none, and helper function of root dot right path and key. Okay, just So we are, if this is the case, if this is, if any of the two argument here is true, then we will simply return the return true statement, right? Return true, right? And if this is not the case, then if any of this if statement is not executed, then we just simply want to remove the root of the root from the path. So path dot pop, and return false, right? So let's see if this is working or not. So we, what we want is we are going to pass root, and let's say we want to find uh, right, path path 1 1, let's say, equals to helper root path argument root path 1 comma and p, and similarly path 2 is helper root, yeah, 2 and b, and this path 1 2 and path 2 2 will be the boolean value true or false, because we are returning the boolean value. So let's see if this works or not. So simply we just, well, we just simply print the path 1 uh, path 2. Let's see if this works or not. Just we are printing, this is not the answer yet, but just we want to make sure all the variable function is right. So it is printing 3 5 6 2 7 4 1. I think there is something wrong with the code. Well, let me see again, and I will. Yeah, there is a problem here. We have to pass q, right, not p. So let's see. Let's write further. Let's say if there is a path from p to q, and path from root to p, and path from root to q. If both the condition are, if both the condition are true, then we will move further. So here we will write if path 1 1 and path 2 2, if both are true, then we will proceed further, or else we just simply return, because if there isn't a path from root to p, or isn't, if there isn't path from root to q, then we simply can't find any common ancestor, right? So else we will simply return. So if this is the case, we have path from path for p and path for q, then we will compare uh, the elements of these two array. So what we are going to do is we will use a variable I and while loop, while I is less than length of, say, path 1, and and I is also less than length of path 2, then we will proceed further. If path 1 I ith element of path 1 is not equals to ith element of path 2, then if this condition holds true, then simply break at that point, break here, and for I plus equals to 1, right? So and the answer would be return uh, path 1 I, just just the element which is just before the ith. That's right. Let's run the code. Yeah, there is a pop. Typo. Run this code again. Let's see if they can add a list out of index. This thing, what is happening here? Yeah, I think this will work now. This will work. Yeah, answer is matching. Your answer is 3 and the expected answer is 3. Let's see if it gets accepted or not. So submit here, and yeah, it get accepted. You see here, we just simply we used a very simple algorithm to find the path of this mm, node. We have to find the path from root to this element p, and we have to find the path from root to element q, and then simply using then simply compare them, and if that is true, if there is a different element in both array, then at that point we break, and we simply return the value which is just before that element, right? So we have used here a helper function which is just finding the path, and just common if else statement to solve this question. I hope this helps you, and stay tuned. Please subscribe to my channel, and I will be posting these videos lately, so stay tuned, and thank you for watching my video.